guys, welcome to my video segment on measuring the water that is coming out of your supply line into your irrigation system. This is a very important video. You need to know approximately how much water is coming out of your supply into your irrigation system, so you're able to understand how much water is available for the crops or for what is to come out of the back end of your irrigation system. We are going to measure the water coming out in the rate that it's coming out, which is the volume divided by time. So we're going to use gallons per hour, and we may do some calculations to convert it to gallons per minute. That is basically what is used when you're starting to look at different emitters, how much water comes out of the emitters. So if you have 10 emitters releasing a half a gallon per hour, that is essentially you need 5 gallons per hour to come in from your supply. That's pretty simple math. You have 10 emitters, half of a gallon per each emitter. So that's 5 gallons, and they distribute that volume of water over 1 hour, 5 gallons per hour. So if we don't have 5 gallons per hour coming out of our spigot or our main supply, then we will not have that water available to come out the back end. So we need to know the rate the water is coming out. The next measurement that we need to know is the pressure that the water is coming out. This is a pressure tester that I picked up at Home Depot. It costs roughly $4 to $5. It's very important to know the pressure that the water is going to exert on your irrigation system and the components downstream. Different components have different tolerances or limits of the amount of pressure that they can hold. The tubing may be rated for 50 to 60 psi. You may have a filter that's only rated for 40 psi, and the emitters need a certain amount of pressure to fire correctly. Some may need low pressure compensating drippers may need 5 psi, and other emitters may need as much as 30, 40 psi if you want them to fire correctly. So we need to know the initial pressure to ensure that we have the correct pressure and determine what type of pressure reducers we are going to need downstream. So the way we're going to do this is basically calculate for the flow rate. We're going to calculate a volume divided by time. I'm using a 1 gallon jug, and I'm going to count how long it takes to fill a 1 gallon jug and divide it by the time. That will give me gallons per time. And then I can convert that time into hours. So basically, you can use a 1 gallon jug, you can use a 5 gallon Home Depot bucket. Essentially, if you can use a 5 gallon Home Depot bucket, you put it underneath, you fill it up, and you time it, how long it takes to fill up, you divide it by the time, and that's still going to be gallons per hour. So I'm going to go ahead and get started, and I'm going to measure my time it takes for a 1 gallon jug. This is going to be an approximation. I've already done the measurement quite a few times and took the average of a few fills to get it. But we're going to just kind of show you how it's done. So we're going to open up the spigot all the way and then time it. Okay, Okay, so we have a jug here now that it's about, I would say, 3/4 filled, 2/3 filled. But I'm also going to guesstimate how much water we saw at the very end spray out. And I'm going to say roughly the amount of water that sprayed out is about what it would have taken to fill here. And I'm going to guesstimate roughly 10 seconds it took to fill this. That sure makes the math really easy. So it took roughly, well, we know there's 3,600 seconds in an hour. Okay? And we know that it took roughly 10 seconds to fill a 1 gallon jug. So we know that there's 360 10 seconds in an hour. So we know it took roughly 360 gallons in 1 hour. 1 gallon took 10 seconds. So if I did this 360 times, I would get 3,600 seconds. So I now know my flow rate coming out of my faucet is 360 gallons per hour. It seems like a lot, and something to keep in mind is this doesn't mean I can put in 360 1 gallon emitters per hour, because we have to keep in mind other considerations such as any type of water usage within your house or on the supply line that is going to be coming to feed your irrigation system. So if I hypothetically put in, and I measure this exact to be 360 gallons per hour, and I want to put in 360 emitters that are firing 1 gallon per hour. What if someone flushes the toilet inside my house or takes a shower? Now we could time if we're going to use a timer, we could time our irrigation system to fire maybe at 4 a.m. if no one in your family uses the shower at that time, or other types of supplies. So there are ways around it, but I want to make sure I have water available all the time for whenever my trees need water. So I'm going to take into a buffer, and I'm going to reduce that 360 gallons per hour later on when we talk about the emitters and the layout of your irrigation system. Okay, so let's move to the next step. I got 360 gallons per hour coming out of my spigot. Now let's just test the pressure. So the way we do this is put the pressure tester on. You don't want to over tighten it. There's an O-ring in here that you could damage. Okay, we turn it on. Okay, and make sure it's on all the way. And I have 80 psi. The red thing is just a marker to kind of mark the top of it. But again, I have 80 pounds per square inch. Now, if I was going to be hooking up my hose directly to this would not work. The hose is only rated for, I think, somewhere between 50 and 60 psi. If we're receiving 80 psi, then we're going to have some damage to the hose. But what we're going to do throughout the entire process is measure the pressure after various components that are going through your system. Various components will reduce the pressure, and it could be anywhere between 5 psi, 15 psi, all the way down through the length of your hose. And longer your hose is, that will also reduce the pressure. So we're going to talk a little bit about that in future videos. So how to know where we're getting pressure loss to ensure that we have the proper pressure throughout the entire system. Thank you very much for watching, and let's move on to our next step. Thank you.